Hello everyone. In this video, I am going to explain you about voltage series feedback circuit and gain calculation of voltage series feedback circuit. These two are the outcomes of this today's video. First, let's see what is voltage series feedback circuit. Okay. Here observe, this is the voltage series feedback network. Here observe, the input side is connected in series and the output side is connected in parallel to the feedback network. And here RF resistor and R1 resistor forms a feedback circuit. Okay, here R1 and RF forms a feedback circuit and the input of the feedback is V0. V0 is the output. Normally V0 is the output of our voltage series feedback and input to our feedback circuit, and Vf is our output of the feedback circuit, and this Vf is equal to the V2 because this Vf terminal or feedback terminal is connected to the inverting terminal of the op amp, that is nothing but V2 voltage. Okay, here Vf is nothing but V2. Now coming to here, let's see, RL is the load resistance and VIN is the input voltage. Okay, here let's see, V1 and V2 are the two input voltages and the total input voltage, that means differential input voltage, is nothing but V1 minus V2. Okay, and A is the open loop gain of this op amp. Okay, now let's see here, A equal to large signal voltage gain, or simply we call the open loop gain, and RF and R1 forms a feedback circuit. Now we know open loop gain is nothing but output by differential input. Here observe, output is nothing but V0 and the differential input, that is V1 minus V2. V1 minus V2 is nothing but VID. Okay, VID. Now coming to closed loop voltage gain. Here in closed loop output also voltage also V0 and closed loop input voltage is VAN. Here one thing remember, open loop voltage, that is open loop input voltage, is nothing but differential input voltage, that is V1 minus V2, and closed loop input voltage is nothing but applied input voltage at non-inverting terminal. Here we are connecting non-inverting terminal as a input. Okay, that's why VIN, I consider the VIN as the input of closed loop feedback amplifier, and the gain is AF is equal to VIN by, sorry, V0 by VIN, that is output by input. Now coming to gain of the feedback circuit. Gain of the feedback circuit we denoted as beta. Here gain is nothing but output of the feedback circuit by input of the feedback circuit. Here observe, the output of the feedback circuit is VF. Okay, here observe, the output of the feedback circuit is VF and the input of the feedback circuit is nothing but our output of the feedback circuit, not a feedback circuit, our output of the feedback amplifier is nothing but input of our feedback circuit. Here observe, V0 is our input of the feedback network, that is gain equal to Vf by V0, where Vf is the output of the feedback circuit and V0 is the input of the feedback circuit. Now let's see gain calculation of voltage series feedback circuit. Here we know in negative feedback the input voltage, that is differential input voltage, that is VID equal to, we know VID is equal to V1 minus V2. Okay, V1 minus V2, where V1 is nothing but VIN. Let's see here, V1 is nothing but VIN and V2 is nothing but VF. Okay, remember this point, and let's substitute here, V1 is nothing but VIN and V2 is nothing but VF. The feedback voltage always opposes the input voltage. Here input voltage is VIN. This input voltage is always opposed by the feedback voltage. Let's coming to closed loop voltage gain, that is AF is equal to V0 by VIN. V0 is nothing but output of our closed loop amplifier and VIN is nothing but input of our closed loop amplifier. Now coming to here, let's move this. Okay, it is the output of the normal, then I mean this is the output of the open loop op amp or open loop amplifier, that is V0 is equal to amplifying gain, that is A into input is nothing but V1 minus V2. Okay, that's written here. V1 V naught equal to A into V1 minus V2, where V1 equal to VIN. Okay, let's find here. V2 is equal to VF. Already told you V2 is nothing but the output of the feedback circuit, that is VF. Here let's see how to find the VF. Means VF is nothing but the voltage across the R1 resistor. Voltage across the R1 resistor is nothing but VF. We know according to voltage division rule, the voltage at particular resistor is equal to the total voltage into that resistance by total resistance. Here observe, total voltage is nothing but V0. V0 into that resistance is nothing but R1 by total resistance is nothing but RF plus R1. Let's see here, the same thing is written here, that is VF is equal to V0 into R1 by R1 plus R2. Okay, V0 into R1 by R1 plus R2 is the voltage of the output voltage of the feedback circuit. Now these all things substitute here, that is in the output expression. V0 is equal to A into V1 minus V2. V1 is nothing but VIN and V2 is nothing but V0 into R1 by R1 plus R2. Here let's see VEN. Let's see here, if I do the LCM for the previous expression, then I can get this expression, that is nothing but V0 equal to A into VIN into R1 plus R2 minus R1 V0 by R1 plus R2. Now here multiply A, that is gain, to the inner terms, then we got the V0 equal to A VIN minus A R1 V0 by R1 plus RF. Okay, here move this term is nothing but A R1 V0 by R1 plus R1 into this side, then we can get V0 plus A R1 V0 by R1 plus R2. Okay, equal to VIN. Now take common as V0 in this expression. Now I can get V0 of 1 plus AR1 by R1 plus RF equal to AVIN. Okay, now take LCM here. Then V0 of R1 plus RF plus AR1 by R1 plus RF equal to AVIN. Now consider A is very large and neglect R1 plus RF in numerator. Here consider this A, that is nothing but gain is very large, and these two are very small when compared to this gain, and neglect these two terms, that is R1 plus RF, then our numerator will be like this. V0 of, here V0 of AR1 by R1 plus RF is equal to AVIN. We know we are going to find the gain of the closed loop op amp, that is nothing but gain is nothing but V0 by VIN. Okay, that's why move this VIN to this side, then we can get V0 by V1 equal to, move this term to this side, then we can get 1 plus R by R1. Finally, V0 by VIN is nothing but AF. AF is equal to 1 plus R by R1. This is the required gain, or the gain of the voltage series feedback amplifier. Okay, this is the gain, that is AF is equal to 1 plus RF by R1. I hope you understood this topic. Thank you for watching this video.